Am I audible? Can you hear me? So, if you can hear me, let's start. Today we are going to study about rotation in three dimensions. Uh, Before starting the tutorial session, I will ask you to have a copy and pen with you so that you can take notes that will help you while later on you will attempt the quiz of the day. Just a moment, I must silent. Fine. So let's start. Yes, we are going to discuss now about rotation 3D. Before diving deeper into different facets about rotation in three dimensions, let us at the beginning get a graphical object of graphical perspective of rotation in 3D and try to observe how does it actually look like in three dimensions. So this is our Blender software. Once again, the disclaimer is that I'm not an expert of using this software. This is basically a 3D animation creation software. But I think you can visualize different things here. You can see the 3D object is there in the center of the three-dimensional coordinate system. There is your coordinate system. Yes. Now, let me try to rotate. So, this thing. You can see that this red circle is basically your x-axis. This green circle is your y-axis, and this blue circle is your z-axis. Now you might think that we always know that our primary axis are basically straight line, but if you observe carefully, we actually draw the Cartesian axis onto some flat surface. Now, what we perceive as flat surface is basically a circular one. If you think of the surface of our Earth, or surface of our Earth is basically a circle. So when you draw a straight line onto the surface, it is basically nothing but a tiny arc of a very large circle. In that way, you can think the entire line, unbounded line, as a circle, and this tiny portion you can assume as the visible portion of your primary axis. So that is another thing. Let me try to rotate this thing. Now you cannot actually arbitrarily rotate the object in three dimensions. Arbitrary rotation is not possible. What you have to do is you have to get hold of one of the primary axis, and then you have to rotate this object getting hold of that primary axis. This primary axis might work like a screw. So you see I have got hold of the x-axis and I am rotating the object now. So similarly you can get hold of the y-axis, the green line, and apply y-axis rotation. You can see that the y-axis is being rotated. Similarly you can get hold of the z-axis and apply rotation. So in three dimensions, basically three types of rotations are possible. Rotation with respect to x-axis or x-axis rotation, then y-axis rotation, and z-axis rotation. So this was a graphical overview of the rotation thing. But now we try to look into this mathematically. First we draw our primary axis system. In 3D you will have three primary axes. Now into Blender you have noticed that these axes were defined as circuits. Now here makes sense. You can see that these three lines are basically can spread up to infinity. So if this line travels in this direction, what will happen? It will travel the entire surface of the world and will come back to hit this point. So this is our x-axis, so this is our y-axis, and this is our z-axis. Now if you have observed carefully, you might have noticed that you can rotate an object in three-dimensional space by getting hold of one of the primary axes. So what you can do is you can get hold of the x-axis and turn it in clockwise or anti-clockwise direction as if you are holding a screw. In that case, what will happen? You can see that your x-axis will not change its position, but you will get your y-axis somewhere here. Doesn't actually look like a straight line. Let me make this make these lines dotted. So what actually happened here is you have used the x-axis as a screw and rotated it into this clockwise direction. And in that course, what happened, or what will happen, more precisely if I say, x-axis will not change its place, but you can see that y-axis and z-axis will get displaced. So if you have a point P here into the original XYZ coordinate system, it will be somewhere here after rotation or x-axis rotation. So particularly what will happen here is that as x-axis have not changed its position, the x-coordinate value of this newly formed P dash point will be same as that of original point P, but y and z coordinates of P dash will be different from the y and z coordinates of P. In that way, you can say that x dash will be equal to x, y dash will be not equals to y, and z dash will be not equals to z. So this was x-axis rotation. Now you can do the same thing with y and z coordinates also. So to do y-axis rotation, what you have to do is you have to use the y-axis as a screw, and you have to rotate getting hold of the y-axis either in clockwise direction or in anti-clockwise direction, this one. So by rotating the entire space by getting hold of y-axis, after rotation your x coordinate will be something like this and z coordinate will be something like this, but there will be no change in y coordinate values for the objects residing in 3D space. Similarly, you can rotate all the objects which are there into our three-dimensional XYZ plane by getting hold of the z-axis. In that case, you have to use z-axis as the pivot line, or as I have mentioned, you can assume it as a screw, as if you are rotating a screw. You can rotate the entire 3D space getting hold of the z-axis either in anti-clockwise direction, this one, or in clockwise direction. And if you do like this, say we have done anti-clockwise direction rotation, you will get your x-axis somewhere here and y-axis will be displaced to somewhere here. So when you apply z-axis rotation to the objects residing in this 3D space, for those objects there will be no change in z coordinate values, but x and y coordinate values will be changed. So from whatever we have discussed until now, you yourself can conclude that in 3D space the rotation is something different than 2D. In three-dimensional space, rotation can be either x-axis rotation or y-axis rotation or z-axis rotation. So one thing lastly, before getting into the mathematical facets, I would like to mention, uh, say for the time being, when you apply z-axis rotation, there will be no change in z coordinate values, but x and y coordinate values will be changed. In that sense, you can say that in xy plane, basically a two-dimensional rotation is happening. Or if you can imagine an original object P before rotation, and after rotation the rotated point is P dash, the situation will be like x dash will be not equals to x, not x. Y dash will be not equals to y. Z dash will be equal to z. So you can ignore this thing, but if you follow this first two equations, you can think that this is basically something like rotation in two dimensions. If you can recall the discussion about rotation in 2D, you can find that when you rotate a point in two dimensions, both the x and y coordinate values get changed. And here something uh, like that is happening. So these equations will be same as that of two-dimensional rotations. So first we try x-axis rotation and things will be clear to you. Let me draw our primary axis system. This is x-axis, y-axis and z-axis. Now if you doing x-axis rotation as we have discussed before, there will be no change in x coordinate value. You can see that in x-axis rotation, uh, in sorry entire rotation is going to take place into this yz plane. So after rotation, the rotated point will be somewhere here. So you can think of this rotation as if you are rotating a point onto the yz plane by an angle of theta. So your equations will be y dash same as that of 2D, y cos theta minus z sin theta, and z dash will be y sin theta plus z cos theta. Now we can introduce the homogeneous 1:1 at the end of the three equations. So if you convert these equations into a single equations in matrix form, your rotation matrix will be something like 1 0 0 0. Here you will have cos theta, then minus sin theta, 0 0 sin theta, then you will have cos theta, 0 0 0 0. Last row is for homogeneous coordinate system introduction. So here is our rotation matrix for x-axis rotation. X, Y, Z. So this is your x-axis rotation matrix, and we have studied x-axis rotation. Now let me try to apply 3D rotation along y-axis, or let us try our hand on y-axis rotation. For that, we draw our primary axis, x-axis, y-axis, and z-axis. Now you have to apply rotation with respect to y-axis. That means you have to rotate a point P by getting hold of the y-axis. Y-axis will now act like a screw. Now after rotation, you will get your rotated point, say somewhere here. You can see that, like our previous discussion, everything will seem like as if rotation is taking place onto the xz plane, and there will be no change in y values. So after rotation, before that, let me clarify the things a little bit diagrammatically. You can think of the rotation as a two-dimensional rotation onto the xz plane by an angle of theta. Now let me draw our equations. So x dash equals to x cos theta minus z sin theta y dash, there will be no change in y coordinate values, and z dash equals to x sin theta plus z cos theta. That we append homogeneous 1 equals to 1 at the end of three equations. Now if you combine these three equations into single one, you will get the y-axis rotation matrix, and the rotation matrix in y-axis cos theta 0 minus sin theta, shortage of drawing space. Just one thing I will like to say here, take notes whenever you think is necessary, because the notes will be helping you while attempting the quiz. Now the row for z-axis equation sine theta 0 cos theta 0 0 0 0 1. So there is a cursor here. This is your rotation matrix for y-axis rotation. If you multiply the right hand side of this equation, you will arrive at the same conclusions as happened in these four equations. So this was y-axis rotation. Now let me try z-axis rotation. For z-axis rotation, you have to rotate the 3D space by getting hold of the z-axis either in clockwise or anti-clockwise direction. So your rotation will seem like as if it is taking place onto the xy plane, and after rotation the resultant point is P dash. So from our prior discussion you can conclude that there will be no change in z coordinate values. X and y coordinate values will change as if rotation is taking place on the xy two-dimensional space. So x dash will be x cos theta minus y sin theta. Y dash will be x sin theta plus y cos theta. Z dash will be equal to z. At last you have to append 1 equals to 1 for homogeneous coordinate system purpose and convert everything into a single equation. Let me do it a little faster. No, it is difficult to draw onto the board using mouse. I cannot go much faster than this. Cos theta minus sin theta 0 0 sin theta cos theta 0 0 0 1 0. And last row for homogeneous coordinate system. Here we go. Our z-axis rotation matrix has been constructed, and multiply the z-axis rotation matrix with the original point x, y, z 1. Done. So this is your z-axis rotation matrix. If you multiply the right hand side of the equation, you will arrive at the same conclusions as we have arrived using these four equations. Write it here. Z-axis rotation. So this was rotation in 3D in terms of x-axis rotation, y-axis rotation, and z-axis rotation. So it is now time for the quiz. Uh, as of the previous sessions, in this session also, this is not live yet. I have to edit it. Box 20, no due date. That's not the topic. Quiz. Yes, I have assigned it. You can try it from Google Classroom, and I'm also going to post the link into the chat box. Classroom, where is it? So here you have 10 questions, all are mandatory as we did during the previous sessions. Try the questions yourself, be honest, don't get the answers from your friends. Here goes the link from Google Classroom. Here is the direct link for you. I have just posted it into the chat box. So it is 12 past 3 minutes in my clock. I think the questions are not that much difficult. 10 minutes will be sufficient to complete the whole quiz. So we will end our quiz session at 12:13. So make the time 12:15. Say ends at 12:15. Don't get the answers from your friends. Try them yourselves. Ooh, someone is already done. Don't do it in a hurry. Read the questions carefully, then click on the answer. This quiz will have no bearing on your university grades. This is for your own understanding. You have 10 more minutes in your hand. We are almost near the end of the quiz session. Only 4 minutes left. And until now, we have 13 responses. We are almost 17 responses. 18. I hope most of you are done with the quiz. Today I can see one thing. Most of you have missed the correct answers. And frequently missed questions are in this matrix zone. Shatik, 18 out of 20. Yes, there is no one who got 20 out of 20. The reason might be you have not taken enough notes. You see, today's quiz had something where not much reasoning was there. Moshihud, 18 out of 20. So, this quiz was an example of why you need to take notes of certain things. Actually, if you look into the matrices, these questions are asking for the matrix values itself, where there is not much room has been left for reasoning. You have to simply remember that thing. So, if you have taken notes, it would have been helpful. 12:15. Now I'm stopping accepting the responses for some time. The time is over. You can attempt the quiz later on, obviously. Uh, Before starting the discussion, I want to say one thing. Today, I'm going to upload one assignment into the Google Classroom. And the reason is you might know that university has asked for internal numbers. In Google Classroom, I can see that some of you are not present yet. So I have to make sure that all of you are actually attending the class, not the live sessions, but at least you are accessing the materials. So those of you who have been attending the live sessions, fine. And those of you who are not being able to attend the live sessions, just convey the message to them to attempt the assignment within due date so that I can uh, make proper input into the university sheet. Otherwise, I have to make them absent. I'm left with no other way. So let's start our discussion about the quiz questions. Yes. First question goes like, rotation in 3D as a whole can be achieved by a single matrix. Now, let me go back to our discussion. This is basically the handout which I'm going to hand over to you after the class. You can see that to achieve rotation transformation in 3 dimensions, you need to employ three matrices, three different matrices. One for x-axis rotation, another one is for y-axis rotation, and another one is for z-axis rotation. So rotation in 3D as a whole cannot be achieved by a single matrix. So the answer is false here. Next question. How to zoom it bigger. In x-axis rotation, changes take place in which plane? You were given three options: xy, yz, and zx. For that, let me once again go back to our discussion. This thing. So, the page here. Yes. So the rotation in question is x-axis rotation. So here is your x-axis, y-axis, and here goes our z-axis. Now, if you apply x-axis rotation, if you can recall our discussion during the tutorial, you might have noticed that the rotation will take place in YZ plane. After applying x-axis rotation, the YZ plane will be displaced something like this. This is your displaced y-axis. This is your displaced z-axis. So rotation will take place in YZ plane. Which equation is a part of z-axis rotation? Now, if you can recall the z-axis rotation, you can remember that when you will apply z-axis rotation, the changes will take place onto the xy plane. Point P, after rotation, it will be displaced to point P dash. Now, among P and P dash, z coordinate value will not get changed. That means z dash equals to z after rotation. So the correct answer, correct answer is this one. Last option, z dash equals to z. Yes. some of you have already done, please type your university roll number into the chat box for record purpose, as we are near to the end of today's session. In x-axis rotation, the rotation can be thought of as a 2D rotation in YZ plane. We have discussed this before. The answer is going to be true. Now, here you have a tricky question. In x-axis rotation matrix, the question is, yes, in x-axis rotation matrix, the value at 0, 0 location is 1 x cos theta or 0. For that, to find the answer, you have to look into the rotation matrix. Here is your x-axis rotation matrix. You can find that at location 0, 0 of the two-dimensional array, we have a 1. So the correct answer is 1. Let me move to the next question. Suppose you have applied x-axis rotation on the point 0, 0, 0. What will be the resulting point? This question is a little tricky. Let me take one page and I will draw the primary axis, x-axis, y-axis, z-axis. Now the point which need to be rotated is this one, 0, 0, 0. So the solution goes like, if you apply x-axis rotation, what we have noticed that y and z coordinate values will get changed, but you can see that whatever changes happen there, the origin will be same. There will be no displacement in origin. So in that sense, after you apply x-axis rotation or y or z-axis rotation, the point 0, 0, 0, that means origin of the Cartesian coordinate system, will not get changed. It will be same. So the correct answer for this is the second option, 0, 0, 0. Now, next question. In x-axis rotation matrix, the value at 1, 1 is 0 cos theta or minus sin theta. So for this, you again have to visit the x-axis rotation matrix. Now this is the column indices of the two-dimensional array or matrix, and these are the row indices for the two-dimensional array. Now for x-axis rotation matrix, the value at location 1, 1 is this one, cos theta. So the correct answer is the second option, cos theta. Now all the remaining questions will go like this. In y-axis rotation matrix, the value at 1, 1 is. So you have to revisit the y-axis rotation matrix and just write down the indices. 0, 1, 2, 3, the column indices goes like, and row indices goes like 0, 1, 2 and 3. And the question was asking for the rotation matrix value at location 1, 1. So you can figure out that the value at location 1, 1 is 1. So the correct answer is this one, first option, 1. Last question for the day. In z-axis rotation matrix, the value at 0, 0 is 1 cos theta or 0. Let me revisit the z-axis rotation matrix. So at location 0, 0, we have cos theta here. So the correct answer is the first option, 1. So this was all about today. One thing at the end I will like to reiterate that if you think that you have not been able to grab the concepts in proper way, just go through the study material once again later on, then watch the tutorial video which I'm going to upload in the Google Classroom, then attempt the quiz once again honestly. Don't copy the answers what I have discussed now. Make sure that you have understood the logic, reason behind the answers, and then only put a tick on the correct answer. I'm going to make this quiz live once again so that you can attempt it as many times you like. And one thing you must remember that I'm going to upload the assignment. This assignment will be necessary for university evaluation purpose. All of you must attempt the assignment and submit it within stipulated time. And those of you who are not present here, please let them know. Convey the message to your friends and classmates. So that was all for today. Have a great day ahead. I'm now going to disconnect. Bye.